So anyway, good morning. Now, I've given you an assignment on the IAS, no, and I have already uploaded the part of the solution. Okay, I'm only going to solve the sum and average. Okay, for the IAS. No, I'm not going to solve. Let me move this. No, move ko na lang. Okay, tapos na itong iba eh. Okay. Dapat it should be after the looping concepts. Okay. Sum and average with loop. You can download the worksheet now, and then we will discuss the answer today. Okay. Your problem was to compute the sum and average of three numbers, and you also have computations from centigrade to Fahrenheit, no, and that's all, no. So what I'd like you to do is to do looping, no, with the IAS. Now you also have an assignment, no, due next Monday, which is what okay, which is to do average. No? This is a simple assignment. Okay, write a program to compute the average of the first three numbers using with the PDP one, no, with loop, and give a trace. No, I will discuss the assignment shortly. No? But before that, let me give you the answer to the programming assignment for the IAS. The main reason I'm trying to show you this is because I'd like to show you the evolution of the programming, different ways of programming from old computers, no, to newer ones. And you will see that I'd like to emphasize the point that programming becomes easier and easier, no. Aloha becomes easier as computers evolve, because of course, no, the programming difficulties are obvious, and so the manufacturers improve their architecture so that the programmers will have an easier job. Okay, so anyway, here where is that, no? Sum and average for the IAS, no? Let's look at the sum first. Okay, let me erase that, no? Let me erase the now. This is a top-down loop. Okay, this is a top-down loop version because we could not have a bottom-up, no, top-down tayo, because we have shown earlier that the bottom-up loop will not work for the IAS because of the difference between jump plus and CF, no. Do you follow? Fortunately, in the later computers, we will not have this problem anymore because there are so many conditional jumps that are provided, no, in the instruction sets, no, in the later computers, no, even in the IBM 701 and the PDP-1 series. No? Okay. So there are no more. In other words, programming is easier. Okay, because of the conditional jumps. This is the main issue. No? This is the main issue in the IAS. There's only one conditional jump, and thereby it makes it harder to program. Okay, so like the multiplication, rather the factorial program, this is a repetition of steps. Instead of computing the partial product, we will compute the partial sum. Do you follow? No? Okay. Partial sum. So we will just replace the multiplication with the addition. Okay. First, we will load negative of M1 because this will be our this will be our loop counter, no? Then add M2, so the real content. I'm sorry, this is negative 3 because M1 is positive 3. So if you have add M2, we have negative 3. M2 is 1 plus 1. So this is negative 3. Okay, do you follow? So we have been doing this, no? So negative 3 plus 1 is negative 2. So that's why later when we say store M3, this negative 2 is transferred to M3. Okay, do you follow? We'll erase this because yeah, we have to trace this ourselves. So store M3, we are in a jump plus. Obviously, it will jump if the accumulator is a positive value or a non-negative, which means 0 or above. No, jump plus means non-negative. Now, since this is a jump to a tail, and the accumulator is a negative value, do you follow? The jump plus will not go to the tail, okay? Because it will only jump plus if the accumulator is 0 or positive, okay? Any questions? So will we jump plus here to 9, which is the command, the next command after the tail? The next command after the tail is just jump to itself. No? Remember, this is the same factorial program. You have replaced the multiplication with addition, okay? So obviously this will not do a jump. We will proceed here, okay? Add M1, okay? What is M1? It's currently, we are going load M3 now, sorry, load M3. No? Now this M3 is a load absolute, okay? Load absolute of M3. So we will have 2 because we are going to load the absolute value, okay? Now, if the instruction set of the computer does not include an absolute, it's easy to compute. You just compute the negative of the negative, no? And then you can even do a check. Okay, if it's a negative value, you can do a check using a conditional jump. Okay, so load M3, absolute of M3. Add M1. M1 is currently 3, so this will be what? This will be 2 plus 3. So this is our partial. This is 5, no? Which is our partial, our partial sum. Store M1, so we are going to store it here. So this becomes 5. This is M1. Okay. Hindi natin ano. This is 5. Okay. Any questions so far? 5. Okay. M1 becomes 5 from the accumulator. So we say load M3. M3 is negative 2. So this becomes negative 2. It's no longer absolute. No? Then what? We add M2. So we have negative 2 plus 1. So this is negative 1. Okay. And then jump 5 to 19, which means we will not have any option but to go back to 50 to 19, but to go back to the head of the loop. Okay. Where we have negative 1 for the AC. We have 5 for M1. We have 1 for M2. And we have negative 2 for M3. Do you follow? No? Do you follow? So ito yung AC. M1. M2. M3. Do you follow? No? These are our latest values. Any questions? Cordova? Any questions so far? So we repeat the process because we jump to the left of M of 5. Okay. Store M3. So AC will have negative 2. So sorry. M3 will have the AC. So this will become negative 1. We follow M3 will receive AC. Take note, no? M3 will receive AC. Okay. And then jump plus. If the accumulator is positive or 0, we will jump to the tail, but it's not, so we'll just proceed. Load absolute of M3, so this becomes 2 because the absolute value, no, 1, I'm sorry, no? Absolute value of negative 1. Add M1, so this will become 1 plus 1. Add M1, no, 1 plus 5 because M1 is 5. So this becomes 6. And we store M1, so this becomes 6. Do you follow? We have computed the partial sum. Then we compute the next addend. No? Load M3. So the accumulator becomes what? Negative 1. Okay. Add M2. So this becomes negative 1 plus 1. This becomes a 0. Okay. And then we go back. Okay. And then we go back up because there's no condition. We just have to go back. So we're in the third pass. We're in the third pass now. No? Do you follow? So our accumulator, what's our accumulator is 0. Our M1 is 6. Our M2 is 1 and our M3 is -1. Okay, -1 ba? Let's look up. Yes, it's -1. And then we store M3. So M3 receives the accumulator. This becomes 0. Then jump plus. Will we jump? Yes, because it's now a 0. So we will go to okay, we'll go to 909 here. So we'll now get a whole. Okay, and our answer is 6, which is the correct answer. Okay, any questions? If you are going to compute the average, it's easy, no? We are going to add a variable. The problem with this is we lose the number 3, which is which should be our final divisor. We should have to divide 6 by 3, but at this point we lose the value 3. Do you follow? Any questions so far? Wala na yung value ng 3, right? So we cannot divide it anymore at the end. So anyway, what we'll do is we are going to insert, no? Therefore, we are also going to change, no? We are also going to change the numbering of our command addresses. Okay, because we are going to insert, no? We are going to hindi na ito M4, I'm sorry, no? This is now because M4 will be stored. Mali, no? This is wrong, no? I might have to upload it again. M4. So 5L ito. I'm sorry, though. This will be 5L. Okay, because 4. This will be 4. Sorry, what happened to my ano? This is 4. Okay. This will be our final divisor. I have to upload this again, no? Do not download it yet, no? This will be 5L. Load M3. This is 5L. This is 5R now. This is 6L. 6R. So anyway, we only add 1, no? 7L. Okay. 7R. This is 8L. 8R. This is 9L. 9R. 10L. 10R. 11L. 11R. 12L. We'll erase the rest. Anyway, it's just like that, no? So now we jump. This is now this is no longer a jump plus 10 because this is 12L. Okay. This will be a jump plus 12L. Okay. 12L, that's correct. It should be a 12L. You follow? And this is no longer a jump to 50 to 19, but this is a jump to 7L. Okay? 7 na siya ngayon. Right? Okay, do you follow? Can we trace this quickly? Okay. So we are going load M3, so the accumulator. It's the accumulator now. Let me expand this. Okay, can you still see my my worksheet? We load M3, the accumulator becomes load M1, sorry, no? Load M1. Because M1 is our partial sum, okay? So load M1, the accumulator becomes 3. Store M4, so M4 becomes 3. We are going to store this here because we are going to divide the result later. This will be preserved. Okay. Okay. They follow. Okay. So load absolute of negative of absolute of M1. So this becomes negative 3. Add M2. So this becomes negative 3 plus 2. Or rather, negative 3 plus 1. Okay. So this becomes negative 2. Okay. We store M3. So this is M3 here. So this becomes negative 2. So M4 is not overwritten. Okay. They follow. So store M3. We have it here. Jump 12 to 19. 12 to 19 is the halt. We will not jump there because it's still a negative. So let's go back. Okay. Dito no. We will not jump. Load absolute of M3. So we have 2. No? So this will be add M1. So we'll have load absolute of M3 is negative 2. M1 is 3. So we'll have 2 plus 3. So this becomes 5. We store M1. So this becomes 5. Do you follow? And then we load M3. This is not the absolute. So this becomes negative 2. Add M2. So this becomes negative 2 plus 1. Do you follow? No? Negative 2 plus 1. So negative 2 plus 1 is negative 1. Okay. And then we go back to, we jump to the L. No? Okay. We go back to jump 7, 0. Okay. They follow. Anyway, we repeat the whole process. But when the zero, when the accumulator becomes 0, okay, they follow. We load the accumulator to M1 or the final values. Remember, this is a 6. They follow. The accumulator becomes a 6, no, and then divide by M4. So we'll have 6 divided by 3. Okay. So the accumulator becomes 6. The final value is in the accumulator. Becomes 2. Do you follow? And then we do a halt. Okay, any questions? I'm not going to trace this anymore. I'm just going to upload this to our website, no? To our Dagler site. Anyway, it's clear, no? It's clear. We don't go back there. We load M1 because M1 is our final answer. Okay, our final sum. And then we divide it with M4, which is our final divisor, which we saved initially at the beginning. I hope it's clear, no? So that we don't waste time tracing it all over again. Okay. So anyway, what I'm going to do is I'm going to update the site because there's a slight mistake. Where's that? The sum and average. Saan yan? The sum and average of the IAS. Okay. Ito. This is the solution, no? This is our solution to the problem. Okay. So any questions so far? Any questions so far? Okay. What I'd like to explain to you is the next program, okay? So, excuse me a while. No? It's okay. Okay. Excuse me a while. So anyway, what I'd like to show you is this, no? Wala pala akong video. Forgot this. Anyway, I have this. Is the programming language, the handbook of the PDP-1. Okay? Which is the next. No? We will it's a little advanced, no, because the PDP-1, remember that the IAS was finished in 1952 and the PDP-1 was, which is a computer which was introduced in 1959 and was commercially sold during 1960. So there's about 7-year gap, no? But there are many computers in between, no? So by the way, sino bang wala sa atin ngayon? We have Alcantara is here. Yep.
Sir, present, Sir Valmoria, sir.
Memoria.
Sir.
Sir, present rin Mercado, sir.
Huh? Can you chat,
Mercado.
can you chat me now so that I can, please chat me now. Please write on the chat so I don't forget, no? Okay. Anybody else? Ramis. Anybody else? Chat me now. Okay. I'd like to show you the handbook, no, because the original manual for the PDP-1 computer is not complete. Meron siyang kulang na mul. Okay, let's look at this, no, the handbook. This looks okay. So it's almost the same. The PDP-1 is almost the same as the IAS, except that there's a lot of improvement, no? First, it has a CRT display, which means that it has a TV-like display, no? Let's look at PDP-1. Meron na siyang TV. What's this? PDP-1 computing. PDP-7 ito. No, we're looking for PDP-1. DEC. It's by DEC, Digital Equipment Corporation. There it is, no? PDP-1. We already have an image. Okay. Ito, this is the DEC PDP-1. It already has a monitor. Take note. Now, it has a tape. In 1959 ito, in 1960, it was sold commercially by 1950. This is a second generation computer, which means it's made of transistors, no? Second generation. 1969, 1959, 1960 is the formal, no? Second generation. Now, it uses a typewriter for a keyboard. Do you follow? This is the same thing, oh. No? I'm not sure which one is the correct, but the original, I think, has a circular CRT because monitors during the time are TVs during the time are circles, no? Circular. There's also another PDP-1. It has a CRT display and it uses a typewriter as a keyboard. Now, this is not the first computer which has a keyboard because earlier, no, there was already Manchester Baby during the Second World War, okay, which was in Cambridge, no, in the UK. It already has a computer keyboard. But this is the first computer, the very first computer with a CRT display. Do you follow? No? Siya yung first computer na merong monitor. Okay? It uses a light pen. There's also an oscilloscope display, a card punch control, card reader and control, no? Like the 701. Okay? I'll take note of Chavez anyway. First. Chavez. Narca is already here. I think I've already checked. Narca. Hindi pa. So it has a magnetic tape. It has a parallelogram. It's like a hard disk. It has a line printer. It has a printer. No. Now, the important difference between this, no, between the PDP-1 and the IAS is the bit size is uniform both for the instruction and data. This is an 18-bit computer. Okay, this is an 18-bit computer, regardless whether it's instruction or data. Do you follow? Unlike the 701, IBM 701 is IBM's version of the IAS. It is a 36-bit by 18. Do you follow? The IAS is 40 by 20. The 701, which came in after EDVAC, is 36 by 18. So which means it also has a left and a right. Do you follow? Now the PDP one doesn't have a left and right anymore, which means it's much easier to program. Do you follow? Do you follow? And it has indirect addressing. We will discuss that in our future, in our future discussions, no. So add y. Now in the these are the instructions. Okay, we had add y, no. Do you follow? In the IAS we say add m of y. Do you follow? No. In the PDP one we say add y. Okay, they're the same. The contents of the AC, C contents of AC are a sum of the contents of the memory y and the original AC. So it's the same, no? Add y. Sub y. In the IAS we say sub m of y. Okay. Mul y. Okay. In the IAS we say mul m of y. Now there are complications here, but for integers, mul and divide are the same. Okay, do you follow? Mul and divide. We'll just in our program we'll just be multiplying and dividing integers. But remember, this is what's that? Is this a fixed point or floating point? Let's look at that. The number system is fixed point. Okay, so no problem. No, maybe for the 18-bit is divided into two. No, for real numbers it will take two registers. So 36 bits pa rin, 18 yung whole number and 18 yung range. It's called the range, no? And 18 for accuracy, which means the decimal places. No? Okay. Any questions so far? So let's go back, no? Okay. And then index, we will skip that, no? ISP. It has logical operations, no? Can do exclusive OR. Load accumulator. Do you follow? Ibuyan is present. Si Ibuyan. Di ba si Ibuyan sa Sa hapon pa kayo? Di follow? Ibuyan kayo ng dalawa ni Serbo. Is that correct? Am I correct, Miss Ibuyan? But anyway, it's okay if you're here, no? Because you are listed according to my list as 4-310. Okay? It's okay, no? You just attend again if you like. Because I'll have to check your attendance again anyway, no? You follow? Anyway, so remember in the IAS we say load m of y. Okay? Okay, it's okay, no? Buyan, it's okay. And then in the IAS we say load m of y. In the PDP one we say lock LACY. Do you follow? No? Now in the IAS we say store m of y. Okay? Depth. Now depth, no? Depth y, no? Iba yung it has a deposit accumulator DAC. Okay, deposit accumulator DAC y. Okay? We say store m of y. This is the equivalent of store. Do you follow? No? All the rest are the same. Mul, div, add, sub. Now there's a jump. The jump is JMP. They follow jump to an address. This is the same jump of the IAS. It's said that it has changed the spelling. No? Jump. JSP, we'll skip that. It's not important. There's also call JDA, jump and deposit, which means before it jumps, it deposits the accumulator. Now these are the important, no? The conditional skips. SAS, skip if accumulator and Y are the same. SAS Y. Okay, so much it's easier, no? To do an if then else. Okay. Now let's look at the skip operations, no? So these are just mga shift bitwise operations. Okay. Skip operation, skip group. This is the skip group. This is the most important part. Skip On accumulator 0. SZA. Okay, do you follow? This will only skip one line. Okay, it will advance one extra position. Do you follow? If this in the instruction, in the sequence, and the next instruction is skipped. Okay. Okay. Now, this is not the equivalent of jump plus because exactly 0. Okay. Skip on plus accumulator. Okay. The sign bit is of the accumulator is 0, which means it's positive. Okay. 0 is positive, no? So this is like jump plus. Do you follow? Now, skip on minus accumulator. This is like CF. Do you follow? SMA. So, in other words, no, in the following in the following architectures, those that follow the IAS, there are so many jumps that are supplied, so that you no longer have even to worry the structure of the loop that you will use, diba? In the IAS, we know that there are certain loops which will not, where the top-down structure will not work, so we'll do a bottom-up or vice versa. In this case, you can do everything you like, okay, because you have the sufficient jump instructions. In fact, for the modern IBM PC, no, there's so many jumps, no? The modern Intel that we have, there's so many jumps, no? It's equivalent to the DEC PDP-1 also. In fact, there are more jumps. Can we look at this? So IBM PC, the modern IBM PC, there's so many jump instructions so that you don't have to worry about how to structure your loop. Okay? Ito, no? Jump instructions in the IBM PC. These are conditional jumps. Okay? Jump if overflow during a division, no? Jump if not overflow, if there's no remainder, no? Jump if sign, which means that sign flag, which means negative, no? Jump if not sign, if it's positive. Jump if equal, jump if 0. There are so many jumps, no? Jump if greater than, there's probably an equivalent for jump plus and CF, no? Always, I think, for sure, there's an equivalent. So you don't have to worry about what type of loop you will write. You can just do anything, no? Do you follow? Okay. So you will have a programming assignment, no? What you will do is compute the average of the first n numbers, only the average, okay? Do you follow? In fact, I have an example. No? I have a sample program for the PDP-1 there. The factorial program with loop for the PDP-1. Okay, we'll just convert the IAS bottom-up loop. Okay, bottom-up loop. I have it here, no? The PDP-1 loop factorial, no? This is the same function. Actually, this is the same function as that of the IAS. Do you follow? Let me just erase this. In fact, if you look at bottom up lang ito, no? Bottom up. If you look at the codes, the micro instructions, they're the same. You follow? What I did is just copy this. Okay, these are the same. Okay, what I changed is translate it to the language of PDP-1. Do you follow? No? This is the loop factorial for the PDP-1. Okay, so ONA is AC receives M1. We have load M of 1, right? No? If this were the IAS, we may say load M of 1, but this is the PDP-1, we say lock 1. Okay, so load M of 1, this becomes 4. Do you follow? Sub, in the IAS, we say sub M of 2, right? Okay, dito we say sub 2. Okay, I'm sorry, no, this is 4. Okay, this is 4. And then we say sub 2, so this becomes 4 minus 1. Do you follow? So this becomes 3. Okay, and we say doc 3. Doc 3 is actually store, so this will become 3 will now, this will be deposited here. Do you follow? Do you follow? So different commands, the same. They are synonyms, no? In other words, okay. So LAC1, so the accumulator is now loaded with 1, so this becomes 4. Okay, and then mole 3, so this becomes 4 times the contents of M of 3, which is currently 3. So the accumulator becomes 12. Okay, DAC 1, so now deposit this to 1, so this becomes 12. Do you follow? So the micro instructions are the same, only the and you notice, no, there's no longer a left and a right. Do you follow? Our addressing is now in sequence from 0 upwards. Do you follow? This is the benefit of the architecture where the size of the data and the size of the instruction are the same. Do you follow? This is 18 bits. Do you get my point? 18 bits for data and 18 bits for instruction. So which means that there's no more concern about whether we'll go to the left or we'll go to the right. Why? Because data and instructions are of the same size. Unlike in the IAS where data is 40 bits and instruction is 20 bits. So which means that 2 instructions can fit into 1 data. Right? Dito, 1 instruction in 1 data. Do you follow? So the problem of horizontal jumps is no longer there. Vertical na tayo lahat. We go in sequence. Okay? Do you follow? Our addresses will be 0, 1, 2, 3, 4. We don't have a 5L, 5R, 6L, 6R. No. We don't have that anymore. So the code is much clearer. Okay? So DAC 12. So what we will have here? LAC 3. So load 3. So the accumulator becomes 3. Okay, sub 2. This is 3 minus 2 or minus 1. So this becomes 2. DAC 3. So now we'll deposit this here. Okay. Now here's the skip if 0 accumulator. Do you follow? Here's the difference. Here's the main difference. No? Because we don't have a long jump. We only a long conditional jump. Skip if 0 accumulator. Is the accumulator 0? No, it's 2. Do you follow? So therefore, we will not skip. We will go to 14. And in 14, we have a jump 7. We'll go back to 7. Do you follow? Jump. JMP is jump. So we'll go back to 7. That's a slight trick, no? A slight difference. Because if the accumulator is 0, we'll just halt. Okay. Jump 15 is jump 15. Okay. So our accumulator here is 12. This is a 2. No, this is a 1. Our accumulator is unstable. I'm sorry. My internet connection is unstable. Oh wow. Are we still online? Why am I unstable? Let me check again now. Speed test. Hindi naman napuputol. I'm not cut off. It's even faster. How can it be unstable when it's faster? Now my upload speed is slow, no? But it's okay, no? I used to have 15. This is 1580. It's only 10, but it's okay, no? Do you follow? So this 12, the accumulator is 2. You follow? This is AC, this M1, this M2, M3, okay? So you have load accumulator 1, so this becomes 12. Okay, do you follow? Mul M3, so this becomes 12 times 2. Okay, so this becomes 24. And we say DAC 1, so this means deposit the accumulator to 1. So this becomes 24. And load accumulator 3, so 3 is 2. So this becomes 2. Okay, sub 2. 2 is our constant of 1. So remember, this is AC. M1, M2, M3. Anong nangyari? Bakit ayaw? Pangit naman. Okay. You follow? So lock 3, load accumulator 3. So 3, this becomes 2 and sub 2. So this becomes 2 minus 1. This is a 1. And deposit this to 3. So this becomes a 1. Skip if 0 accumulator. Accumulator is not 0. So we'll go back 7. Okay. So we'll have to copy this. Anyway, this is in our Dagler site. Okay. The accumulator is 1. This is now 24. This is 1. Okay, do you follow? So lock 1. Lock is load accumulator. So the accumulator becomes 24. Okay, mul 3. So this becomes 24 times 1 because 3 is 1. 24 times 1. So this becomes 24. Okay. And then we dock 1. So this becomes 24 also. Okay. Lock 3. So the accumulator becomes 1. Okay. Sub 2. So this becomes 1 minus 1. Which means you subtract the accumulator. This becomes 0. Okay. Dock 3. So this is now deposited here. This becomes 0. Do you follow? And then we say skip on 0 accumulator. So if since this is a skip on 0 accumulator, this line 14 is skipped. We will proceed to line 15 and this is a halt. Okay, our answer is in M1. Do you follow? So this is just a bottom-up loop translation of the analytical engine. Do you follow? Because we have C as ZA, which will work like a CF. It will work when in 1 minus 1, diba? The CF in the analytical engine will work in 1 minus 1. The same thing with CZA. Skip on 0 accumulator. Do you follow? So the moral lesson here is if the instruction and the data are of the same size, the programs become easier. Okay? If instructions, that's why nowadays in our computers, we don't address, everything is addressable by bytes. No? So when you say an address, that's a byte address, regardless whether it's instruction or data, no? The CPU will just adjust. No? Basta the address is 0 to n. It's not, there's no left, there's no right. Okay? So programs run sequentially from the first command to the last command according to the numerical addressing provided by the CPU. Okay? Any questions so far? No? So that's a moral lesson there. No? The data and the instruction should be of the same size so that programs will be simpler. Okay? Any questions so far? Now there's still enough time for us to tell a story. No? Let me tell you another story. Ito, now, from the 1950s, no? Because 1952 was the invention of where the store program concept was established. No? Okay? To the 1960s, no? There are two dominant manufacturing companies. There are two tech giants. Ngayon, we have a lot of tech giants, right? You have Facebook, you have Google, you have Microsoft. No? In the past, there are only two. There's IBM and no. By the way, if you look at IBM, no, it's 701. Okay, this is like the IAS. No, anyway, we don't have to show that anymore. We will not program this anymore. This is just like that, the IAS. Okay, we'll show you why. No? From 1952 to 1960, this is the time of the vacuum tube computers. No? I think that's the second generation. Okay, because the first generation is the mechanical computers. No? The second is, let me check. It's anyway in our first generation is mechanical. Second generation is vacuum tube. First generation is vacuum tube. No, sorry. Second generation is transistor. Third generation is microcomputers. No? Microcomputers. And then third generation is IC, large scale. Okay. The fourth generation, microprocessors pala, no? Microprocessors, and then so on and so forth. So here's the chronology, no, of the stored program computers right after the IAS. Now, there's something strange here. No? The IAS was completed in 1952 at Princeton College. Now, remember the inventors, no, of ENIAC, Presper Eckert and John Mockley, Eckert and Mockley. Okay, they also produced the EDVAC in 1952, which was also considered a store program concept computer. Which comes first, we do not know. Basta, how did they do this? Because the IAS, rather the store program concept, was introduced already during 1946 or 1945, 1946, right after the war. It was already introduced. Do you follow? Do you follow? It was already, who introduced it? Of course, John von Neumann is credited to having. But how are they able to make EDVAC a stored program concept? We'll look at that later. No? Then in 1951, UNIVAC 1 was also, they're just about the same time. No? UNIVAC 1 also from Eckert and Mockley, which was renamed at this time Remington Rand, or sometime later as Perry Rand, because it's like Remington Rand bought the patents of Eckert and Mockley, and then Sperry merged with Rand, so it became Sperry Rand. Okay. Now Remington Rand, remember, is a manufacturer for famous typewriters. Okay, famous typewriters, Remington Rand. You should have a very good typewriter if you have a Remington Rand. Okay. So UNIVAC 1 is also a store program concept, but was not developed commercially. It was given to the US Census Bureau. Okay, and the IAS in 1952. Now in 1953, right after, no, IBM quickly, they developed their own store program concept. Okay, they call it the 701 EDP machine. No, so there's the new jargon, EDP. This was first invented or coined in 1953 by IBM. When you say EDP, the term EDP stands for electronic data processing. So EDP machine, which is the IBM 701, the first store program concept computer developed by IBM. Okay, it's a 36-bit data, 18-bit instruction computer. So it's like the IAS, except that the IAS is 40-bit and 20-bit. It's a 36 by 18, so it also has a left and a right. Do you follow? So it's a little difficult to program because it's also horizontal. It's fixed point, no? It's not floating point. It has 5-bit of codes and 12-bit operands, so 17. May kulang isa. Do you follow? Maybe they have reserved 1 bit. And like the IAS, it can also have 4096 or 4 kilowords. Okay, like the IAS, it can have 4,000 words in memory. Based on William tubes, these are vacuum tubes. It uses 2 accumulators, and it's built for scientific applications. And remember, during that time, IBM built 19 of this and have it rented for $12,000 a month. It's very expensive. You follow? 1953. Okay, by 1952, they developed another version called 53, no, 55702 to compete with the UNIVAC. The main difference between 702 and 701 is it uses magnetic tapes, no? And it's aimed for business computing. They also built 14. It doesn't say whether they have sold it or they have rented it. Okay, Simon. Okay, it doesn't say, no, whether they have, no, they have rented it or they have sold it, but most probably they have rented it, no, because nobody could afford it at the time. Okay, so they also developed another 704. It's like the 701, but this time uses magnetic core memory, and it can store up to 80K from the previous 4K. They follow, and uses floating point computations, not fixed point. This is the first computer that can play music. They follow, and IBM built 123 units and sold them at 2 million each. They became very rich. Okay, and the sad story is they were manufacturing store program computers without paying any royalty. Without paying any royalty to John von Neumann. We'll find out later why, you know. Walang royalty dito. Okay? Because John von Neumann did not get a patent for the store program concept. Okay? So during those times, manufacturers just are free to develop their own, version because there's no patent for the store program concept. So IBM quickly developed computers and DEC followed suit. Do you follow? Okay, 2 million units each. If you want to buy this, you can contact IBM. IBM 705 was introduced. No, this was a failure. No, the main difference is it can store up to 160K, but this was a failure. They withdrew it from the market. They introduced instead 709 in 1958. This is the first IBM which used the first computer which used a third level programming language. No, it's called Fortran. It was invented by John Backus in IBM. No, okay, in 1956 and was used first in IBM 709. Okay, single floating point, so it can be used with high precision. Alphanumeric codes. So this is the first computer which can process characters. Do you follow? So if you're asked which computer can first process characters, it's the IBM 709. Okay, so meron siyang letters because it's using BCD. And this is a computer which can have several I/O devices which can be connected to it, like printers, tapes, no? Because it can. The primary improvement includes input and output channels. No? Do you follow? And then by 1959, IBM got a competitor from DEC, Digital Equipment Corporation. No? By 1959 to 1961, IBM 7030 was introduced. No? It was sold at 13.5 million and dropped to 7.8 million, and it was later withdrawn from customers. They refunded the customers. DEC on 1959 introduced a new computer. This is the PDP-1. It's an 8-bit computer with a 4 kilo memory. Fixed point, so I've introduced you this already. So 18-bit, both for instructions and data. Okay, it sold. Remember, at initially, IBM 701 only sold how much? 19, but that PDP-1 sold 53 at a very cheap price. No, the low end is $85,000, and the high end is $120,000. It was not considered good, but it gave DEC a lot of leverage. Remember, this is 1959, and they introduced the CRT display. This is the first ever, the first ever during the time, the first computer with a display. It's unstable again. It's unstable again. So really, the internet is having problems. Bakit unstable? Okay. So sold 53. So they made a lot of money out of this, because they sold 53 units. Now take note, the IBM, rather the DEC PDP-1 is very popular. Aside from the CRT, it has a typewriter keyboard, and it is the first computer to run a game. It's called Space War game. I have played this on a different computer. Space Commander ang tawag, during the 1980s. So what is the computer which played the first game? And what is the name of the game? It's called the Space War game. There's still a lot of these versions, which you can download. May mga versions pa rin, DOS-based versions of the Space Commander or the Space War. The later called Space Commander. In 1960, IBM produced the first transistorized. So this is the second generation, no longer vacuum tubes. It sold for 2.9 million and rented for 63,000 a month. DEC introduced a PDP-2, but it was never built. 24-bit. A PDP-3 mini computer was built by other companies. In 1962, IBM built the 7094. This is a very popular version. But PDP introduced the a PDP-4 predecessor of PDP-1, built 35 and sold 65,000 each. Okay. Now, in 1963, IBM developed the S6360. This is now the transistorized versions, to compete with the DEC computers. Now, this is the first computer to run COBOL, a business language, a language that is used for databases. The author is Codacil. It's a group, Codacil is it's an organization of programmers. And another programming language called PL1. Now, DEC produced the mini computer, a 12-bit mini computer, and sold a lot. no? And sold them very cheaply at 27,000, and they built and sold 1,000. No? So 1,000 times 27,000, that's still 27 million. Okay. 1964 to 1965, to 1967, no? Even to 1969, no? IBM just developed updated versions of the S360. So in 1964, PDP tried to compete with, with IBM. They built the PDP-6, which is a mainframe, which is a 36-bit, but they built only 23 and sold 300,000, only 300,000 compared to the 3 million. No, they built 23, only used by MIT. So DEC and MIT were collaborating. IBM and Harvard were collaborating, and then Iowa State was collaborating with. Kasi Honeywell was the predecessor of Tanasoft, and Sperry Rand is collaborating with Penn State. No? So collaboration between manufacturers and universities, because most inventors come from universities. No? Okay. So okay, with PDP-6, 1965 PDP-7, 18-bit, no, the mini computer. It's like the PDP-4 or the built 120, used for real-time control. I think this is already a floating point, no? Sold at 72,000. No? PDP-8 is one of the cheapest, no? It was sold. Some of the universities in the Philippines, no, were able to have this. A 12-bit computer, only 18,500. It's still expensive, no, but the universities could afford them already. PDP-9, 36-bit upgrade of PDP-7, okay, 35,000. Now, 110,000 is one of the most expensive. No? PDP-10, 36-bit computer. And then by 1969, no, PDP DEC developed a 12-bit predecessor of the PDP-8. 1970 was a landmark for PDP, because they sold 600,000 of their PDP-11s. Some of them went to the Philippines, no, at 10,900, the cheapest, and it's a 16-bit. It's also a predecessor of the IBM, of the modern personal computer that we have. Okay. Then PDP-15 came in 1970. Now the sad thing is, the sad thing for DEC, is in 1976, Apple was established. They released the personal computer. This is now 1970s is the period of the microprocessors, which means that this was the time when personal computers were produced, no? Very small computers, no? By Steve Wozniak and Steve Jobs at Apple. They sold it only for $66,600, okay, below $1,000. And then by 1977, IBM stopped producing the mainframes, but they instead competed with Apple. They released the IBM PC to compete with Apple. And then they did not compete with Apple and IBM, which means they did not produce personal computers. Okay. So which caused the decline of DEC. DEC was later purchased by Compaq, and Compaq was purchased by HP. Do you follow? Now you see, the big question is, how are the manufacturers able to build and sell store program concepts without violating any patent laws? Do you follow? That's because John von Neumann did not get a patent for the store program concept. Let's look at the story, no? Let's look at the story, because there's some important matter that we can learn from this, no? Ito yung story niya. The patent issues, no? The patent issues. You can also wiki this from John Vincent Atanasoff, who really invented the first electronic computer in the US, no? Because it was first invented in Germany by Konrad Zuse, or Konrad Zuse. Now, Eckert and Moseley claimed that they were the first to invent the electronic computer, and they filed a patent for ENIAC. And along with that, of course, also the patent of the stored program concept. Although ENIAC was clearly not a stored program computer. Okay, so there's an issue already with the patent of ENIAC. Although the patent was granted, no? The patent was granted, but the patent to the stored program concept was not included in the approval. Do you follow? Do you follow? It was not included in the approval. Why is that? Because during 1944, no, in the development, 1946, I think, no, that John von Neumann published a paper called the first draft report on the EDVAC. Okay, 1946, which completely outlined the concept of the stored program concept computers. Okay, so it was published and authored by John von Neumann. Okay, but it was not contested by Moseley and Eckert. Do you follow? Moseley and Eckert did not contest. However, the registered manufacturer or inventor of EDVAC was Presper Eckert and Moseley. Eckert and Moseley, but they did not contest. Why is that? Because later they found out that Neumann was part of the team that developed the stored program concept jointly with Eckert. Eckert was doing the engineering side, and Neumann was doing the design part or the theoretical part. Do you follow? So they first worked together, but later split. Nag-split sila. Whatever reason, they split. Okay? And so there was a race to create the first stored program concept computer. John von Neumann invented the IAS, and Eckert and Moseley invented the EDVAC, proceeded with the EDVAC, and they were both finished in 1952. So tayo sila. No? Do you follow? Okay. So in 1944, they declared the ENIAC complete, and they applied for a patent. Okay. So John von Neumann paid them a visit and made discussions, no, on the invention of another computer, and that was in 1945 that John von Neumann released the first draft report on EDVAC. No? Now in 1947, Eckert and Moseley was informed by their lawyer that the patent for the stored program concept cannot be awarded to them because that of a previous document published by John von Neumann. So nowadays, the stored program concept is accredited to John von Neumann, not Eckert and Moseley. Do you follow? However, Eckert and Moseley did not contest it. No? Do you follow? But they proceeded with an ENIAC patent to patent a stored program electronic digital computer. Do you follow? So they were the first to have registered an electronic digital computer. Okay, and the patent was okay. Do you follow? Now ENIAC patent was applied for in 1956. Okay, to Sperry Rand, now the owner of Eckert and Moseley. Na transfer na sa kanila, and the cross license patents with IBM. So thereby they're allowing IBM to make computers and without even paying patents because they have made patent deals before. No, this is the US patent number 3 million during the time for ENIAC, a patent for the stored program electronic computer, roughly 18 years after their application. No? So it was released in 1956. Okay. Now in 1973, the patent was ruled invalid. Okay. Honeywell Inc. is already, I think it's owned by John Atanasoff. No? It's a predecessor of John Atanasoff, and Sperry Rand is Eckert and Moseley. They were sued for patent rights. Okay. It was ruled invalid. let's find out why. No? Why was it cancelled by the court? The patent for ENIAC was cancelled by the court. Okay. So, Honeywell versus Perry Rand. Honeywell company was speaking in behalf of John Vincent Atanasoff. John Vincent Atanasoff, remember, is the inventor of the ABC computer in 1936 or 1937 in Iowa State, di ba? They were the first to develop an electronic digital computer. Although the problem with their ABC computer is that it's not programmable. It was developed to do a particular application. No? Do you follow? So in 1968, the lawyers of Honeywell, speaking in behalf of Vincent Atanasoff, sued, no? Issued subpoenas for the relevant files of Sperry Rand, IBM, and Moore School of Engineering regarding the design and the production of ENIAC and EDPAC projects. Now, Dr. Atanasoff, John Vincent Atanasoff, was called by the court to testify. No? And then, because their claim was Eckhart and Mockley did not invent the digital computer. They just copied a lot of the concepts from the ABC computer. They follow. So this is a long story. I'd like you to read this, okay? They follow. So Atanasoff was called to the witness stand. Mockley was called to the witness stand. And then in the end, no, this was what came out. No? Mockley had a lot of access to the work of Atanasoff and Berry because they were invited to be a guest to Atanasoff's house during 1941. And Atanasoff and Clifford Berry showed them their work. Okay, they had 1 or 4 days. They went into the office and the physics building of Iowa State, and he was allowed to observe the Berry computer. And he had seen demonstrations, and he was given a 35-page manuscript on the construction of the Atanasoff and operation of the ABC computer. So he was given, and he studied it. He went back, no, and written letters, no, about his enthusiasm, and he took a crash course on electronics at the University of Pennsylvania. Why is that? Because Mockley is a mathematician, unlike Atanasoff is a physicist, no, so he knows electronics. So Mockley did a crash course in electronics, and he came out with the difference between analog computers and pulse devices, no, and incorporated those that were identical on the paper of Atanasoff, written on the 35-page manuscript given to him. No? On 1941, Atanasoff wrote a letter. Or rather, Mockley wrote Atanasoff a letter to suggest the development of a new computer. That was then the development of ENIAC. So the verdict was the patent was cancelled because ENIAC was taken largely from concepts of the ABC computer invented by John Vincent Atanasoff. So which means that the design of the ENIAC and EDPAC were not original. Many of the concepts were just copied from the ABC computer. Okay, so the patent was cancelled, and consequently, manufacturers were able to build, manufacture, and sell stored program computers without paying any patent rights because there was no patent. Do you follow? What's the difference between a patent and a copyright? A copyright is a right to copy. It applies to programs, no, essays, no, paintings, no, works of literature, poems, no, a right to copy. A patent is a right to copy and manufacture and sell. Do you follow? So therefore, this is something that IBM and DEC don't have to comply with, because in the first place there was no patent, and it made them very rich. No? Until nowadays, no, manufacturers can develop or manufacture their own stored program concept computers. No, IBM had an initial patent for the IBM PC, no? But I'm not sure. I will study the actual case, because there were IBM clones as there were Apple clones. So I guess there was no patent violation regarding the development of clones. But later, no, even patents will expire. Okay, so that nowadays, no, several companies are producing the IBM PC. Do you follow? No, it's the whole story. Where's, do we have? Did I miss anything this year? Did I miss anyone? So that's the whole story. No? That's the story of the first generation computers. There was plagiarism. Okay, there was plagiarism at the start. Okay, from that, this is from, the story happened from 1945, no, 1945 to 1960, 1952. Do you follow? 1960 was already the time of DEC. Okay, so we will look at the different, no, we will continue with history of computing. The first generation computing, the second, the main difference is vacuum tube yung first generation computers, no. Look at this, no. So these are the first generation computers from 1940 to 1956. Harvard Mark I, which is not a stored program concept. This is where bug was coined. ENIAC in 1945, the controversial computer. IAS, which was conceived in 1945 but was released on 1952. Okay, kasi nag-race, there was a race already. Okay, and then EDVAC was first conceived, was first developed in 1949, but it will actually started, the first draft report was produced in 1946, which means that the actual research started in 1946. The first draft report was authored by John van Neumann. Okay, this was released in 1952 together with okay, and 1951 was released by Eckert and Moseley. Okay, 1954 dito sa IBM 70 something, no. Okay, 1952 to 1956, these are vacuum tube computers, no. Vacuum tube computers. DEC was not yet here, so IBM dominated the tech market, the technology computing market, no, during the early 1950s and even the late 1950s. They had no competitor. Okay, do you follow? These are the first generation of computers, no? Okay, so the main development during the first generation was a stored program concept. Okay, do you follow? We will continue with our history, no. I think we are done with our programming. We will look at certain, no, important points, no, important events in history, and we will look at history of the IBM PC, the monitor, history of the monitor. We look at Apple also, no, because we have history of microcomputers, no. Dito yung Apple. Okay, do you follow? Okay, bakit wala? Let's look at that, no, because Apple was invented in 1974. I'll enhance this, no. May kulang yung aking there was no we will choose Apple, no. Okay, and then we look at the history of Microsoft Windows, no. And then we'll also look at the history of the internet. Okay, the history of the internet and the World Wide Web. Okay, the history of Microsoft Windows, and then we'll have a formative test. I'll give you a sample test, no, practice test. Okay, by the end of August, I think, no. So meron tayong third week to practice, and then the last week will be will be more or less the schedule of the first formative test. It's a long test, 100 items, no. Everyone, the formative test is a 100 item test. Some of them will be problems, some of them will be objectives, multiple choice, no. Okay, true or false. Okay, I'll give you a practice test anyway, no, for your study tips. Okay, brief history of the internet, we have that, no? Okay, so history of computing, that's the main topic, no. This gives us the evolution of computers. I hope we had enough, no? I hope we had enough, no? Because the next will be number systems, no? Because we will look at the structure of CPUs, no? Which will require us to understand binary arithmetic. And then, yes, we'll have basic logic circuits before we go into basic computer hardware, no? Components of a computer system, and then we will have programming at the end, no? We'll do HTML and so on and so forth. Any questions? No? So our first formative test by the end of August. Okay? Okay? Okay. Thanks for coming, everyone. If you have no questions. No. Thank you very much. See you next meeting. You have an assignment, no? For the PDP one. Okay? Okay. Thank you very much. If you have no questions, we'll end the session. I'll upload this anyway, no? So thank you. Thanks for coming. End the
Thank
meeting
you.
now.
Thank you, sir.
Thank you.